All right, folks. For the past little while, we've been working on graphing sine and cosine functions. Today, we're going to work in the other direction, and given a graph, we're going to be expected to write the equation that would have created this picture. Now, if you look at this picture, this could be a sine curve or a cos curve. It all depends on where you consider starting. And some people immediately look at this picture and consider it to be a sine curve. Others consider it to be a cos curve. But the fact is, it could be either or. When you see the word sinusoidal, it could be the sine function or it could be the cosine function. So we'll talk more about that. But before we get into it, let's review what we know about this type of a function. So every equation that we've been playing with, whether it is sine or cosine, there are 4 different items that can be changed to change our function. And remember from last day that the A is representative of the amplitude. And the amplitude can be found by comparing the max minus the min divided by 2. It is the greatest displacement from rest, and that can be found using this formula. The B value is often considered to be the period, but that is not true. The B value is related to the period. Remember, the formula is period is equal to 2 pi divided by b. Now, of course, that 2 pi is dealing with radians. If we were dealing in degrees, it would be 360 divided by b. And this formula could be converted into b equals 2 pi over the period, based on bringing the b to the other side and then getting the period to the right-hand side. The c value is what we have called our phase shift. As you know, that is the movement right or left. Opposite of the symbol. Keep in mind that in order to determine this, you may have to factor first. And the D we considered the vertical displacement. The vertical displacement is moving what we have been calling the middle of the graph. That is moved up or down, same as the symbol. And we're used to that from all of our function and translations. A useful formula for this also is included. We discussed last week that the vertical displacement is equal to the minimum plus the amplitude. All right, so let's now try to make an equation that will model this function. And it all starts with what you consider to be the starting point. Where is this curve starting and where is this curve ending? Now, some of you immediately are going to say that this is your starting point. Others may be choosing this as a starting point. Either way you slice it, if you chose either of these two positions, then you are playing with a cosine curve. If you start from a max or a min, you are considering a cosine curve. Because, as you know, cosine starts at a maximum and travels. Now, if you're looking at this as your starting point, then that looks like a typical cosine curve. But if you're starting with this point, that is not typical. Cosine typically starts above. So then this would have to be a negative cos curve, whereas this one would actually be a positive cos curve. Where would you start from to actually consider a sine curve? In order to start a sine curve, sine curves actually start at the middle. So in order to start a sine curve, you would have to start here, here, or here, or here. Which one of these items would be a positive sine curve, and which one would be a negative sine curve? Yes, this would be a positive sine curve starting spot, because sine curves start by going up and then down. This was going up and then down. Because this curve starts by going down, it would have to be a negative sine curve. So if we're starting from the middle, then you are considering a sine curve. So let's do it with both sine and with cosine. Let's do both of them today. So let's start with this point here. Let's start with the cosine curve first. So y equals cosine. We said that this is a positive cosine curve, so meaning that this is going to be a positive value. Now this a, the b, the c, and the d, we have to replace with numbers. So a is based on amplitude. And the amplitude formula that we have is max minus min divided by 2. Or we have said the greatest displacement from the middle. Well, this is the middle. So my amplitude is how much above I am from that middle, and my amplitude is 10. This is 15, this is therefore 25. So my amplitude is 10. If I wanted to look at that based on the formula, well, my max was 25 minus my minimum is 5, divided by 2. 25 minus 5 is 20, 20 divided by 2 is 10. My b value is related with my period. If this is the starting of my cosine curve, when am I ending my cosine curve? And hopefully you're saying right here. If this is my start, then this is my end, because that's where my curve starts to repeat. It starts to do the same type of travel that it was doing before. So my period, in this case, runs from negative 20 all the way over to 140. So my period is equal to 160. I've traveled from negative 20 to 140. That's 160 units of travel. Now remember, period is not this value. Period equals 2 pi over b, or b equals 2 pi divided by the period. Well, my period is 160. In lowest terms, 2 pi divided by 160 is pi over 80. So my b value can be replaced with pi over 80. My C value is my phase shift. So in order to start in this location, how much has this graph moved right or left? Well, typically cosine starts at 0, 1. Clearly this one has been moved left from 0, and it's been moved left 20. So I need a 20 in place of C, and should this be a positive or a negative? It should remain a positive because it's going to move left or right opposite of the symbol. So this is telling us to move left 20. And lastly, our D, our vertical displacement. Bad habit here is for people to say that my vertical displacement is 25. That is not true. The vertical displacement is based upon the middle of the graph. Where is the middle of this graph? Well, it's been moved up. It typically is at 0. It's typically on the x-axis, and the middle of the graph has been moved up to 15. So my D value is 15. It's plus 15 because it's been moved up. Now we could also consider the formula. The vertical displacement equals the minimum plus the amplitude. Well, my minimum was 5. Plus my amplitude, which we had said earlier was 10. And 5 plus 10 is 15. So there's the equation for the cos curve for this function. We also want to consider the fact that it doesn't have to be a cos curve. You could calculate an equation that will represent this function using a sine curve. So press pause and try to find yourself a sine curve equation that will represent this function. Your sine curve for this function will depend on where you start. If you start at this positive sine location, let's do that. So we're playing with a positive sine function. The amplitude is still the same value. The period is still the same 160. Therefore, the B value is still the same value, pi over 80. My movement left or right is different, though, because now I'm starting from this point, not this point. So my starting location has been moved left 30, 40, 50, 60. In order to move left 60, I need a plus 60. And my vertical displacement has not changed at all because it's still the middle of the graph. The middle of the graph is still 15 units above where we started. Notice then that regardless of whether you pick a cosine curve or a sine curve, the only value that has changed is your phase shift. And that will be true no matter what. The amplitude of this curve has not changed. The size of the waves have not changed. The period has not changed. The vertical displacement has not changed. So those values will always stay the same. It's only the phase shift that will change. Now, we did not need to play with just this point or this point to represent this function. We could also have picked, perhaps, this point and played with a negative sine function. If we played with this point as our starting point, then our amplitude is still 10. We're playing with a sine function because we're starting at the middle. The period and therefore the B value have not changed. My phase shift has changed because this is my starting point and I've moved right 20. If I've moved right 20, I need a minus 20. My vertical displacement has not changed. But because this function is not starting by going up, but rather starting by going down, that is not normal for sine. That is a negative sine function. So there's many different places that we could have started our function from. You either want to start it from a middle position or a maximum or a minimum position. Most students find it easiest to start with a cosine function But be careful of the middle, that you don't consider the vertical displacement to simply be the height of the curve, but rather it has to be the middle. Now, we haven't looked at it yet, but we should also consider looking at these functions on a graph to compare. Okay, we're back. So as we were saying, we wanted to compare this on the graphing calculator to make sure that we have the correct equation. So because we were playing with pi over 180 as our b value, we're playing in radians. And again, we're always playing in radians unless told otherwise. So we want to make sure that our calculator is in the mode of radians. Now if we go to y equals, we can put in the equation that we have created. Doesn't matter which one you choose. And type it in. Being careful of proper brackets and closing off the brackets appropriately as well. Now before you go to the graph, of course, we always want to check out our window. And I just recommend using a window similar to what the graph paper is for what I've given you. So I gave you a graph paper that's running from negative 70 over to somewhere around 200. And I may as well put it in the same scale, which was 10. And my y values went from negative 5 to a y maximum of 30. And in a scale of 5. When I look at the graph, then I should be seeing the same type of curve that I saw before, and I can verify that by pressing trace and, you know, looking, well, when it's x is negative 20, my y value is 25, which is exactly what it was supposed to be. And when x is 20, my y value is 15, which is exactly what it's supposed to be, and I could check out other ones as well. So it's a good habit just to check it out in your calculator to make sure that you are correct. Again, I want to stress it to you, the only thing that can change based on the same picture is our phase shift. At this point, you should press pause and check out whether or not you can create an equation for the volume of air in the lungs. This one's a little trickier to do, but I think the middle would be about right there. And because that right there is on the y-axis, I would take that as my starting point. If that's my starting point, the curve is starting on the middle, therefore it is a sine function. That point there is hard to tell exactly its y value. So for my amplitude, I'm going to be playing with my formula, max minus min divided by 2. My maximum is 2700. My minimum is 2200 divided by 2. And I should get an amplitude of 250. My b value is equal to 2 pi over the period. Well, my period, this graph starts to repeat once I reach this location. And that is a horizontal travel of 5 units. So my b value is 2 pi over 5. I have not moved right or left at all, so I can leave that for horizontal displacement empty. And my vertical displacement, remember, is how much has the middle moved up on this graph. And that value might be hard for us to recognize what it is. So the other option is to say that the vertical displacement equals the minimum plus the amplitude. The minimum was 2200. If I add my amplitude of 250, I'm going to get 2450. And that's my function. Now, if you use this point and used it as a cos curve, that's fine. This would be a positive cos curve starting location. The 250, the 2 pi over 5, and the 2450 would not change. The only thing you'd have to figure out is this horizontal movement, right or left. In order to figure that out, you'd have to consider the fact that this is moving, or this has a horizontal period of 5. So remember that this location is a quarter of the way along the trip. So half of 5 is 2.5, and half of 2.5 is 1.25. So if you had a cos curve starting from that location, you could have the equation of 250 cos 2 pi over 5. We are moving right, so it's going to be minus 1.25 plus 2450. Either way you slice it, I think the easiest one would have been to use the starting point that I did with the sine function. So how much air is in the lungs at 12 seconds? Well, 12 seconds is the time along the horizontal axis, and 12 we could simply travel up, identify that value, and a lot of students are going to tell me that it's 2600. Well, how could we find it exactly? Exactly, we want to know the y value when x is 12. So I would type this into my calculator, or my sine function into my calculator. And do trace of x equals 12. And if you do that, you will get a height, or a volume in this case, a y value of 2,596.95 milliliters. This is the volume of the lung at 12 seconds. And of course, we already figured out after how many seconds are the lungs fully inflated for the first time. That occurs right here, and we've shown you that that is 1.25 seconds. If you were unable to follow that method that I showed you before, another option is, with our calculator, simply doing second calc maximum. And second calc maximum will give us a value of 1.25 seconds. At this point, you should press pause and try out the next graph and its questions. This one is much harder because it involves some approximation, but it shouldn't be too bad. I would probably recommend we start with this location. It's a maximum, and in which case it's going to be playing with a cosine function. So y equals cosine. If I start here, this is a maximum, so therefore it's a positive cosine function, and I'm going to run through the same things that I did otherwise. My amplitude should be 3. My b value will be pi over 6.2. My horizontal phase shift looks to be 4.5. Again, that's going to be a minus 4.5 because it's moving to the right. And the middle of my graph, well, halfway between 2 and 8 is 5. If I had a sine curve, as you know, nothing would change in this equation except for my horizontal phase shift. My sine curve would have to start halfway between 2 and 8, and that occurs at 5, and that location looks to be 1.5. So it would still be a minus because I would be moving to the right 1.5. Now, if I look at this graph for letter B, the depth of the water at 3 p.m., well, 3 p.m. is not right here. Notice that we've gone from a time of day of 12 to 13, so we're playing with the 24-hour clock. So 3 p.m., based on the 24-hour clock, is a time of 15. So I would plug my equation into my calculator. I would trace at x equals 15, and you're going to get a height of 6.71 meters. At this point, in order for me to show this to you, I'm going to need to type that into my calculator, so I'll just press pause while I do that. Okay, so I have the equation typed into my calculator with the appropriate window that I've been given. And we've been asked to, for how long in the first 12 hours is the water 6 meters or higher? Well, at this location, the water is 6 meters deep. So that time is somewhere around 2. And at this location, the water is 6 meters deep, and that time is somewhere around 7. Every bit of time in between here, the water is greater than 6 meters deep. So really, what we need to figure out is exactly when did this occur, and when did this occur. Your calculator won't let you type in a y value of 6 with trace. So we're simply going to have to do that within y equals. We want to know when the water is 6 meters high. And once we have that line graphed, we're going to do second calc intersect to find the intersection points here and here. Now when you do that, those intersection points will be found at 6.929 and 2.070. Now I'm asking for how long. Well, at 6.9 hours, it's above 6 meters. At 2.0 hours, it's above 6 meters. How much time is in between there was going to require us to subtract. And it is above 6 meters for 4.858 hours. Again, I found this by plugging in y equals 6 and doing second calc intersect 2 different times. Once to find 6.929 and once to find 2.070. Okay, and the last question for us today then is our Ferris wheel question. We are a passenger on the Ferris wheel, and some of us don't know what a Ferris wheel is, so I put the picture of that in the very first part of our chapter. This is a Ferris wheel, right? You get on these at the fair and at the P&E, and you get on and then it rotates around. And what we're interested in is a curve, an equation that represents the height of the person over time of travel on the Ferris wheel. So as you know, time is always independent, and time should be along the x-axis, and height should be along the vertical axis, because my height depends on my time. Now it says that the passenger gets on at a point 1 meter above the ground. So at time 0, I should be at a height of 1 meter. It rotates once every 40 seconds, so at 40 seconds, I should be back at the height of 1 meter. In which case, at 20 seconds, I should be at a maximum height. How high will I be at that point? Keeping in mind that this is a Ferris wheel that has a radius of 20 meters, so the highest point above the ground will not just be 20, but it'll be 20 plus another 20, plus the 1 that I'm sitting above the ground in the first place. So my maximum height should be 41. And basically, the rider will travel along in this fashion. And this should look to you like a sine or a cos curve. That is one rotation where the person gets on at time 0 and is at the back at the bottom at time 40, and that is one rotation. So we're supposed to determine the equation, and we're going to do that in a similar fashion as before. So you should press pause and find your equation. Here is the equation that I came up with. Negative 20 cos pi over 20 theta plus 21. Now, of course, your theta doesn't have to be a theta. It could have been an x or any other variable you wanted to choose. 20 is based on my amplitude, my max minus my min divided by 2. Pi over 20 is based on my period. Remember, b equals 2 pi over the period. My period was 40. 2 pi over 40 is pi over 20. My 21 is the middle of the graph. The number of people probably got this wrong. 21 is not the 1. It's not the 41. It's halfway in between. 21 is also based on the vertical displacement is equal to the min plus the amplitude. 1 plus 20 is 21. And lastly, I have a negative here because I chose a negative starting point, a negative cos curve starting point. I chose this minimum because it hadn't moved right or left at all, and I figured that's a great place to start. It makes it easier in my equation. But that is a negative cos curve if I'm going to start at a minimum. So using that equation then, I want to know where I'm at after 15 seconds. We could ballpark it. 15 seconds is right here. Yeah, okay, we're somewhere in the 30s. We could find it accurately by tracing at x equals 15 in our calculator, and we're going to get a height of 35.14 meters. And two different times when I'm 20 meters off the ground, well, 20 meters is somewhere in here, so it's happening in these locations. And that would be similar to the question on the previous page, where we want to type in y equals 20, do second calc intersect, and we should find times of 9.68 seconds and 30.32 seconds. At this point, you have enough to complete the assignment, which is called Trig Applications Worksheet numbers 1 to 4. I highly recommend drawing pictures of what you're playing with and then following along as we did in the previous 4 questions. Hopefully see you tomorrow with your work completed.